Welcome to Balancing Chemical Equations, a short tutorial. Hopefully you recall the law of conservation of mass, which states that matter cannot be created or destroyed, it can only be rearranged in chemical reactions. So what does that look like in terms of a chemical equation? Well, here you see a chemical equation that's already been balanced, and it's separated into the reactant side and the product side. What we're going to do is we're going to count the atoms that are present in this reaction just to make sure that they are balanced. There's a certain order, though, that we have to list our atoms in, and we call that MENO, which stands for metals first, followed by any polyatomic ions that show up on both sides. After that, we'll list any nonmetals that we have, followed by oxygen, which gets its own place in the order, and finally hydrogen. Okay. So if we look at what we have here, I see K and Br. K is potassium, that's a metal, so we're going to list it first on both sides. And the only other atom left in this reaction is bromine, which is a nonmetal. We're going to list that second. Taking a look on the left-hand side of how many potassium atoms we have on the reactant side, this coefficient of a 2 means that we have 2. And over here, this coefficient of 2 also means that we have 2 potassium on this side. Coming back now to bromine, this subscript of a 2 means that we have 2 bromine. And over here, this coefficient of 2 distributes to this entire molecule. So over here, we have 2 bromine as well. And this shows that this is a balanced equation with 2 potassium on the reactant side and the product side, and 2 bromine on the reactant side and product side. So it's balanced. Let's take a look at these 3 chemical equations, starting with this one right here. Now, before you get to work on balancing chemical equations, one of the most valuable tools that you can have is a pencil with a good eraser. Part of the process of balancing chemical equations involves making some changes on either side until the equation is balanced. And being able to erase the numbers that you put down is something that you need to be able to do. So for this demonstration, a whiteboard marker and eraser is going to work, but when you do it on your own, you're definitely going to want to have a pencil. So we're starting right here. We have the equation that shows zinc metal reacting with hydrochloric acid to produce zinc chloride and hydrogen gas. We're going to start off the way that we started off the other one by counting the atoms that are here. So I'm going to draw a line separating the reactants from the product side, and we're going to remind ourselves of MENO, and we're going to list off the atoms that we have in this reaction. So starting with metals, I see Zn, which is zinc. We're going to list that first. Okay. I don't see polyatomic ions, so I'm going to move on to nonmetals, which I do have, chlorine. List that on both sides. There's no oxygen, but I do have hydrogen, and I'm going to list that last. Okay. And now I'm going to count what I have. So starting on the reactant side, I have 1 zinc, and over on the product side, I have 1 zinc. So far, so good. On the reactant side, I have 1 chlorine, but on the product side, I'm seeing because of the subscript, I have 2 chlorine. I call this a stopper, meaning that I have an atom that is not balanced. I have 1 chlorine over here and 2 chlorine over here, and that's a problem. So before I move on, I'm going to fix that. So I come back to the reactant side, and I need to bring up my number of chlorine that I have, and the only way that I can do that is by putting in a coefficient. I cannot change these subscripts. Any subscripts that I have anywhere in this problem have to stay the same. But what I can change are coefficients. So here's where the chlorine is. Out front of that, I'm going to put a coefficient of 2. That'll give me 2 chlorine to balance it. Whenever you make a change, you want to erase all your counting and start from the top. That's where the pencil with the eraser comes in. So how many zinc do I have over here? Still 1. How many do I have over here? 1. How many chlorine do I have on this side? Now I have 2 because of this coefficient that distributes to the whole molecule. Over here on the product side, I have 2 chlorine. And then moving on, I'm going to count my hydrogen. Well, I put in this 2, so I have 2 hydrogen because it distributes the entire molecule. And over here, I have 2 hydrogen. This equation is now balanced. As you can see in these counts, I've got 1 zinc, 2 chlorine, and 2 hydrogen on both sides of the equation. It's balanced. And all we had to do was put in a coefficient of 2 right here. So moving on to the next one, here's a reaction that looks real similar to the one before, except this time we have aluminum reacting with hydrochloric acid to produce aluminum chloride and hydrogen gas. So we'll approach it the same way. We're going to draw a line down the middle. We're going to list our atoms, starting with metals. Aluminum here. Aluminum here. We don't have any polyatomic ions, but we do have a nonmetal of chlorine. And finally we have hydrogen. Let's count them up. Aluminum on the reactant side, we have 1. Aluminum on the product side, we have 1. So far so good. Chlorine over here, we have 1. Chlorine over here, we have 3. We've hit a stopper, we need to fix it. 3 chlorine on this side, only 1 on this side. Our only option is to put in a coefficient. So we're going to put in a 3 right here. And since we made a change, we're going to erase our counts and we're going to start over. We got 1 and 1 still. For chlorine, because this distributes to the molecule, we have 3. And over here, we have 3. So for now, we fixed the chlorine. Let's check out our hydrogen. Over here, I have 3 hydrogen. Over here, I only have 2 hydrogen. So I've come across another problem. 3 and 2, when you see anything that ends up being 3 and 2, you immediately want to think 6. 6 is the number of hydrogens that we want to get to have this be balanced. So, coming back to the reactant side, just because we put a 3 there doesn't mean that that's permanent. If we need to bring up one of these numbers, we can take this coefficient, we can erase it, and we can change it to 6 because we know we're going to need 6 hydrogen. And since I made a change, I'm going to erase. Sometimes in these problems, you have to do a lot of back and forth before you get it, but it's part of the process. So aluminum, 1. Aluminum over here, 1. Over here, now we have 6 chlorine. Over here, we only have 3 chlorine. We need to fix that now. We can do that though. We need to think of a number that we can put right here in front of the molecule that'll multiply with 3 to give us 6. That's easy enough. We can put in a 2 right there. Okay. How many aluminum do we have? 1. How many aluminum do we have? Well, we put in that 2. Now we have 2. Alright, let's fix that. Coefficient of 2. Count it up. 2 aluminum, 2 aluminum, 6 chlorine, 2 times 3 gives us 6 chlorine, 6 hydrogen, and we still only have 2 hydrogen, but we're going to fix that right here. We need to put in a coefficient that'll multiply with 2 to give us 6, and that's 3. Now instead of going back and erasing all the way, I'm going to skip over a step a little bit. I'm going to say that 3 times 2 is going to give us 6 hydrogen, but the last thing we always want to do is check our work. That's how you know you're right. So let's count them up from the beginning. How many aluminum do we have here on the reactant side? 2. How many on the product side? 2. That's good. How many chlorine do we have over here? There's 6. How many do we have over here? Well, 2 times 3 gives us 6. And for hydrogen, we've got 6 hydrogen here, and 3 times 2 gives us 6 hydrogen there. That one is finely balanced. Sometimes it takes that many steps to do it. You just have to stick with the process, go back and forth, Make only one change at a time and always double check your counts. And you can get any one of these. Here's the last one we're going to take a look at. All right. This one looks really bad. Well, let's just follow the process and see what we can do. We're going to draw on the line. And we're going to list everything out, remembering the order. Okay, metals, I see Fe, that is iron, that's a metal, we're going to list that first. Okay, polyatomic ions that show up on both sides. I'm seeing some parentheses in here, I'm seeing a lot of capital letters. There's some clues that I'm dealing with some polyatomic ions, and I have some. Alright, I see NH4, and we know that's ammonium. Now, if it shows up on the other side, we can list it as a single unit, which is going to make our job a lot easier. And look at that. There's NH4 over on this side. So what we can do is we can list NH4 as a single unit. We can treat that just like an atom. Okay? I'm going to do that over here. Not only that, but I'm also seeing OH, which we know is hydroxide. I see OH over here on the reactant side, and look at that, we have OH over here on the product side. That's another polyatomic ion. We can list that one as well. Okay. And we're going to list it over here. And what's the only thing that we have in here that we haven't listed yet? It's a nonmetal chlorine. Chlorine and chlorine. Alright, let's see if we can balance this now. How many iron do we have over here on the reactant side? There's one. How many do we have over here? Just one. Okay. How many ammonium do we have on this side? Don't get confused by this 4. It's part of the name of ammonium. So if you kind of think of it as how many NH4s do we have? There's just one of them. Okay. How many NH4s do we have over here? Just one. Okay. Moving on. How many hydroxide do we have on this side? OH is a unit of hydroxide. There's only one of them. We've got one. How many hydroxide do we have over on this side? Well, this subscript tells us that we have 3. So we need to fix that. So we've got 3 hydroxide on this side, and we only have 1 on this side. And the only way we can fix that is through coefficients. So we're going to take and put a 3 right here. We're going to redo our counts. Iron, 1. Iron over here, 1. How many ammonium do we have? NH4s do we have over here? Well, since we put in this coefficient, it distributes, we now have 3. How many do we have over here? We only have 1. But we can fix that pretty easily by putting a 3 coefficient. And let's count it up again. Okay? Iron, 1. Iron, 1. Ammonium, which is NH4, we've got 3. How many do we have over here? 3. How many hydroxide do we have on this side? Well, this 3 distributes to the hydroxide ion. So 3. How many do we have over here? Well, the subscript tells us that we have 3. How many chlorine do we have on this side? There's 3. How many chlorine do we have on this side? Well, the 3 distributes over to the chlorine. 3. And that one's balanced.